Hello everyone, and welcome back to another video lesson. In the last video, we looked at two examples of mass-to-mass stoichiometry problems. In this video, we're still going to look at mass stoichiometry problems, but we're going to look at different starting points or different ways they could ask the same question. So let's jump right in. This question says, during World War II, Germany used a method called the Haber process to produce ammonia for explosives. Today, a similar process is used to make fertilizers. If excess nitrogen is reacted with 1.71 moles of hydrogen, how many grams of ammonia, or NH3, is produced? So looking at this problem, there's a lot of fluff in the beginning. The first two sentences are nice information to know, and they help make the problem interesting, but we don't actually need that to solve the problem. The third sentence is what's really important, and this is what tells you what reaction is actually happening here. They say that we have excess nitrogen. Remember, nitrogen as a diatomic element is N2. And we're going to react that with this amount of moles of hydrogen, which is H2. And that's going to create or yield us or produce ammonia, which is NH3. So essentially my reaction is N2 plus H2 gives me NH3. So let's write that out and let's balance it. Remember, your first step in all stoichiometry problems is if they don't give you a balanced chemical equation, you have to create one, and it has to be accurate in reflecting what's happening in the question. So let's see how that looks. We have N2, H2, and NH3 here. If you balance this equation, you find the mole ratio is 1 to 3 to 2. Once I have my balanced equation, now I want to look and see what information is the question providing me as a starting point, or what is my given, and then let's figure out what's my unknown, or what I'm solving for. They tell me here that I have 1.71 moles of hydrogen. So that's my starting point. If I look and find where that is in the chemical equation, that would be this portion right here. The question is asking me how many grams of ammonia is produced. Well, ammonia is my only product, and that's on the right-hand side. So in trying to figure out a strategy for this, take a look at your stoichiometryville map. I'm starting in my moles of my known, and I have to get to grams of my unknown. So this is really a two-step process. I have to convert from moles of what I know, which is hydrogen, to moles of ammonia using that mole ratio of 3 to 2. Once I'm in my moles of ammonia, I can then go from moles of ammonia to grams of ammonia. So let's write that out and let's see how that would look. I'm starting with 1.71 moles of H2. My mole ratio is 3 to 2. I'm basically skipping this first step we saw in the last video because they're already telling me how many moles I have. I don't have to convert grams to moles of this stuff because it's already giving it to me in moles. So I'm going with my ratio of 3 to 2. I'm going to multiply by 2 moles of NH3 and divide by 3. Once I do that, I would effectively know how many moles of ammonia I have in this particular reaction with this set of conditions. The question wants to know, though, how many grams are produced? Well, how do I go from moles to grams? You multiply by the molar mass of ammonia. 14 plus 1 plus 1 plus 1 would give you 17. Again, that's how we got the molar mass there. So if I'm looking at my math big picture, it's 1.71 times 2 divided by 3 times 17. And that would tell me that I have 19.4 grams of ammonia. Let's look at this second question here. Try this one on your own. Pause the video, and once you have it completed, press play to see the results. Okay, let's go through this problem together. It says iron, which is Fe, will react with oxygen gas, or O2, to produce iron 3 oxide. So again, you have to remember how to do your nomenclature and your chemical naming to write this formula properly. How many grams of iron 3 oxide will be produced from 0.18 moles of iron? First things first, before we even look at the numbers in the question, let's get a balanced chemical equation that's correct on the paper. So I find that I have 4 irons, 4 Fe, because iron is solid metal, it's just Fe. Oxygen gas is diatomic, and that's O2. An iron 3 oxide, remember this 3 is the charge of iron, so it's Fe3 plus and O2 minus. So if you crisscross them or if you balance out the charges, you find it's Fe2O3. Then I have to balance the equation. So I have 6 oxygens here on the left, 6 on the right, 4 on the left for iron, 4 on the right for iron. Now let's look at what the question gives us. It tells us we have 0.18 moles of iron, which is this stuff over here, and it wants us to figure out how many grams of iron 3 oxide I have on the right. So let's write down what I know and what I don't know. I know I have 0.18 moles of this stuff here. I'm trying to figure out how many grams would I get on the right. So it's the same process you just did for number 3. I'm going to use the mole ratio first to convert from moles to moles. And then once I'm in the moles of my unknown, then I'm going to convert to grams by multiplying by the molar mass of iron 3 oxide. So let's see how that looks. I have 0.18 moles of iron. I have a ratio of 4 irons for 2 iron 3 oxides. So I'm basically canceling out my moles of iron here, and I'm left with my moles of iron 3 oxide. And then from there, I'm going to multiply by the molar mass. So I have 0.18 times 2 divided by 4 times 159.6. That gives me a final answer of 14 grams. Now you may have gotten some extra decimal numbers afterwards, but remember, we only have 2 significant figures that are provided by the question as my initial measurement as my known. So I have to make sure that my significant figures are rounded properly at the end of the question. Thank you.